Hello everyone. In the last lecture, I was discussing about 8085 microprocessor architecture. I discussed till incrementer or decrementer address latch and a little bit of timing and control circuitry. So here in this lecture, I'll start with timing and control circuitry, and two more blocks will be remaining, that is interrupt control and serial input output control. So these three blocks I'll be discussing in this lecture, and that will be the end of the architecture of 8085 microprocessor. So this timing and control unit generates timing and control signals which are necessary for the execution of instructions. It controls data flow between CPU and the peripherals, that is input output devices, memory, etc. It provides status, control and timing signals which are required for the operation of memory and input output devices. It controls the entire operation of the microprocessor and peripherals connected to it. So here I have shown various signals: control signals, status signals, DMA signals, reset signals. So all these signals are controlled by timing and control circuitry, and they are set high or they are reset as per the instruction. So I'll discuss each and every pin in the pin configuration. I will discuss each and every signal, that is these are all the pins. I'll discuss it in the pin configuration of 8085 microprocessor. So the next block is interrupt control. So what is interrupt? The microprocessor, generally we know the microprocessor fetches, decodes and executes instruction in a sequence. So we know program is a set of instructions, and microprocessor, what it does, it fetches, decodes and executes one instruction at a time, and in this way it sequentially proceeds throughout the program. Now sometimes it is necessary to have microprocessor that automatically execute one of a collection of special routines whenever special condition exists within a program or the microcomputer system. The most important thing is that after the execution of the special routine, the program control must be transferred to the program which microprocessor was executing before the interrupt. That is before the occurrence of that special condition. So this occurrence of special condition is referred as interrupt. Now what happens when microprocessor receives any interrupt signal from peripherals which are requesting its services? It stops its current execution and program control is transferred to a subroutine by generating call signal, and after executing subroutine by generating RET signal, again program control is transferred to main program from where it had stopped. So here I have used two instructions, call and RET. I will be discussing in detail about these instructions in the 8085 instruction set. Now what happens when microprocessor receives interrupt signals? It sends an acknowledgement, that is INTA bar signal, to the peripheral which is requesting for its service. So the interrupt control block has 5 interrupt inputs: RST 5.5, RST 6.5, RST 7.5, trap and INTR, and one acknowledged signal INTA bar. So we will discuss about each and every pin in the pin configuration of 8085. Means I will be discussing about INTR, RST 5.5, RST 6.5, RST 7.5, INTA bar, trap, everything in the pin configuration. And the last block that is remaining is serial input output control. So what happens in situations like data transmission over long distance and communication with, suppose, a CRT terminal, it is necessary to transmit data bit by bit to reduce the cost of cabling. In serial communication, one bit is transferred at a time over a single line. The 8085's serial input output control provides two lines, that is SOD and SID, for serial communication. The serial output data SOD line is used to send data serially, and serial input data SID line is used to receive data serially. So that was all about 8085 microprocessor. Now let's again go back to the architecture, the block diagram, so that you'll get a better idea. Let me explain in brief what I've explained through each and every blocks. So what happens, as we know that the memory where the program is stored, that memory is located outside the microprocessor. Now microprocessor accesses that program which is stored in the memory through address and data bus. So what happens when the program is stored in the memory and the microprocessor wants to access that program? It sends the 16-bit address. The address is of 16 bits because the memory where the program is stored, each memory location has an address, and that address is of 16 bits. So microprocessor sends that 16-bit address through the address bus, that is AD0 to AD7 and A8 to A15, to the memory. So once the memory gets the address, it sends the data that is stored in that memory location address. It sends that data to the microprocessor through the data bus, that is AD0 to AD7. Now if that is the opcode, if the memory has sent the opcode is the instruction. I'll tell you what is opcode and operand later. You just first understand that if memory is sending the opcode, that will tell what the instruction is all about. So that opcode will get stored in the it will go from memory to the microprocessor through data bus, and from data bus it will go and get stored in the instruction register. From instruction register it will go to the instruction decoder, where the opcode will get decoded, and microprocessor will come to know what type of instruction it is, what necessary operations it needs to do, and after decoding the instruction it gets to the timing and control unit, and accordingly timing and control unit sets or resets the control status and other signals to execute the instruction. Now if the instruction is like of addition type, so for addition what will happen, we know addition operation will take place in the arithmetic and logic unit. So arithmetic and logic unit, for addition it needs two operands. One operand is stored in the accumulator, and the other operand, either the other operand is stored in the memory location or in one of the registers, general purpose registers, that is B, C, D, E, H, L. In these registers, from there the second operand or second data will come and get stored in the temporary register. So the two data that are for addition purpose, the two data that will come to ALU, that is one from accumulator and one from temporary register. ALU will perform the addition and store the result again in the accumulator. So this is how everything works. I have explained each and every blocks in detail. I'm ending the class here. Here I have completed the 8085 architecture. In the next video lecture, I'll be starting the pin configuration of 8085 and I'll explain every pin of the 8085 architecture. Sorry, 8085 microprocessor.